I just want to take a few minutes to talk about RapidRatings, but mainly I just wanted to say how delighted we are to be this year's Diamond sponsor. And it's just basically, I suppose, one of the ways that our company can show support to Python Ireland and the community in general. For me, it's a testament to the community in itself that we're all here at a weekend, spending time interacting with like-minded people and sharing ideas. So with that, I just wanted to kind of take a couple of seconds just to kind of introduce you to RapidRatings and what we do. I won't spend too long, but just a couple of seconds. So about 4 years ago, we set up here in Dublin, very, very small, only two of us, as a technology centre for doing technology R&D for the company in general. But there was technology there in existence before we started. So we inherited that technology, and we've been lovingly trying to rewrite that technology for the last number of years. And Sean is going to talk a little bit more about that in a few minutes, about sort of how lovingly we've been doing it. But we've got a great team here now. Of course I'm going to say that, but we have a great team. And it's been growing a lot over the last while. We're now up to 30 here in Dublin. Primarily, as I say, we do all the R&D and all the technology development for the company as a whole. And we've been involved in Pycon Ireland now for the last couple of years, but as I say, this is the first year we've done the Diamond sponsor. So who is RapidRatings and what do we do? As I say, I won't go into too much detail, because what I'd like to do is encourage you to come to the booth afterwards and chat if you want to find out some more information. But RapidRatings is transforming the way the world's leading companies manage enterprise financial risk. RapidRatings provides the most sophisticated analysis of the financial health for public and private companies in the world. The company's analytics system provides predictive insights into third-party partners, suppliers, vendors, and security issuers. Every business conversation becomes more productive, transparent, efficient, and the RapidRatings financial system effectively lends to do all that. So as we effectively ingest more and more private company data and public company data, our data sets get richer, and then effectively we can start to look at economic trends, very interesting insights across global trends in terms of how healthy companies are doing and how much risk is involved in interacting with those companies. So that's the kind of the core of what we do. So just to kind of give you a bit of an idea of sort of the sort of customer base and the ecosystem that we have, it's quite diverse. It's from large multinational banks to insurance companies to McDonald's and Tesla and all these other companies like that. So it's not just one company, it's any or one industry. It's every industry that has counterparties that they deal with. So anyway, as I say, I don't want to go into too much detail about the company. Please come and see us in the booth afterwards if you have any more questions. But one thing I would like to do is basically give a lot of thanks to effectively the volunteers, the staff, the speakers, sponsors to a certain degree. But without those guys doing this work all year long, this wouldn't happen. So I think that without their work tirelessly doing this, organizing all this stuff, these communities don't exist, and it's very important. So I think it's worth giving those guys a big round of applause because they deserve it. So that's it for me. So I just want to go on to the main event now, really. So Sean's going to come up and take it from here. So thanks very much, guys.
How you all doing, guys? It's great to see such a big crowd here. A long time ago, we considered a Python Ireland event to be a success if we had 5 people at it. So it's wonderful to see this community growing so large and strong. So I'm going to talk to you about software rewrites. As Dave mentioned, in the last 3 years, we've spent an awful lot of our time rewriting a lot of our very important, vital core systems. Me personally, I've probably spent most of the last 10 years working on rewrite projects. So I'm going to go through a little of what we've tried, what worked, what hasn't worked, why you should consider a rewrite. When I was starting out in my career, this guy, Joel Spolsky, was extremely influential. He was a very popular tech blogger. I don't think he's quite as well known these days, but it would be worth your while to go back and read some of his backlog. He wrote a very influential article back in 2002, a long time ago now, called Things You Should Never Do, Part 1. And his first thing he said you should never, ever, ever do was do a rewrite from scratch on your software. And the project, the company he was specifically using as his key example was Netscape. Netscape had their browser product, Netscape Navigator, which was completely and utterly dominant at one point in time. The rewrite project that Netscape started was the Mozilla codebase. And you're probably still all familiar with the Mozilla Foundation. Mozilla turned out a product called Firefox, which still has a very healthy share of the market. It generates, I believe, somewhere in the region of $400 million a year in revenue. And this was Joel's example of, at the time, a rewrite which was a disastrous mistake. And he wasn't actually wrong. I mean, if you're Netscape, the company, the rewrite was a disaster. Netscape, the company, no longer exists. As a business decision for Netscape, that rewrite was a disaster. As a technology decision, it was probably an absolute success. And another reason that Joel wasn't wrong was the time frame. Rewrites take a long time. You need to be prepared for it to be a fairly arduous process. If your plan is to rewrite a large, complicated piece of software successfully in 6 months, that's a tall order. You need to be prepared to be in for the long haul on a rewrite, and you need to pick a strategy that means all business does not stop because of the rewrite. So, for another countering opinion, we have Fred Brooks. Anybody who was at yesterday morning's keynote will recognize this quote. It's the second time you've seen it this weekend. Fred Brooks was of the opinion that your first version of your software is always going to be kind of hopeless. You're really just learning the problem domain. You should pretty much be planning to throw it in the bin, walk away, and start again from scratch. Treat it as your learner exercise. If anybody here hasn't read The Mythical Man Month, the fact that 2 of your keynote speakers are quoting it should be a bit of a clue. You owe it to yourself as a working software engineer to get a copy of this book and read it cover to cover. It is timeless wisdom. But I think the truth on rewrites lies somewhere in between. Throwing away everything you write religiously is wasteful. Blindly rewriting anything you don't slightly like the look of is also very wasteful. So, when should you do a rewrite? And it's actually a very simple answer. If you think the effort and the cost you put into the rewrite is going to be paid back by either performance gains or productivity gains afterwards, you should rewrite. And if you think it won't, you absolutely shouldn't. There's no point in rewriting for some sort of architectural ideal of aesthetic beauty. There should be a solid business case. You should be able to step up to your manager and say, I think after this rewrite, we're going to be able to process twice as many transactions, and that's how this is going to keep our organization going. Or I think after this rewrite, we're going to be able to deliver the new features we're planning in half the time. And in 24 months' time, we'll have gotten double the time back that we put into the rewrite. That's how you need to pitch a rewrite project. Here's the investment. Here's the return. The tricky part is your estimate of the effort going to be accurate? Probably not. It's probably going to, it's one of those things where they say, take what you think it'll be and then double it and then quadruple it, and then it's still hard to tell. Particularly if you're working with a legacy code base that's poorly understood, you need to put a lot of padding in your schedule. There are going to be surprises in there that you've never dreamt of. Lovecraftian horrors lurking in submodules. That's a tricky one. But I think this sums up when you'd want to rewrite very, very nicely. If you're looking at this and you're reminded of the software you work on day to day, perhaps it's time to consider a rewrite. But one of the important things to consider when you're looking at this is it's not broken. It works. It does the job it's intended to do. It doesn't have to be broken to require a rewrite. But imagine this is your software project. How are you going to do a change to requirements? How are you going to add a new pathway in the middle of all of this? You can see how a simpler system might let you execute on that a little quicker. Imagine you're the new hire. How long is it going to take you to be productive in doing this? How do you test it? How do you extend it? We need it to be faster. How am I going to speed it up? Will it still work if I accelerate the ball? And finally, how much of this is even necessary? The machine you were looking at here is a switch. That's all it is. It's just one switch. Likewise, in a lot of software systems that have accrued piece by piece, an awful lot of it isn't really necessary anymore. It could be that when you're done with your rewrite, you have something that's only a fraction of the size of what you started with. So bear this in mind when you're looking at your project. Those are the kind of questions you need to ask yourself if you're considering a rewrite. And if you're answering yes to a lot of them, then it might be a good idea. So this is the natural state of software architecture. And that's not as terrible an indictment as it sounds. We all have to make short-term decisions from time to time. There are times when, in order for your business to simply survive, you have to do the quickest thing that possibly works. But the result of the quickest thing that possibly works over time is essentially slum architecture. There's no point in pointing out a gorgeous, modular, modern design of architecture to someone who just wants their kids off the street and dry tonight. That's not what they're going to do. They're not going to spend 2 years planning the requirements for it. They're going to get a roof over their head today, and they'll worry about the other considerations later. Likewise, small businesses, particularly software startups, have to make payroll. If you need that feature out next month because you need the revenue to start arriving in 2 months so you can pay the developers to finally build something better later, this is what you do. And there's no shame in it. Just because a lot of people have a big appetite for rewriting software a different engineer wrote or a different team wrote or they inherited in some way, shape, or form. But they're very cagey about rewriting their own software because they feel they're making some sort of an admission of guilt, that they did a terrible job the first time around. The constraints your organization works in change over time. There's no shame in going back and going, now we have the resources and the time and the breathing space to go back and do this better so that we're better prepared for the future, so that we can get something a little nicer to work with, a little more modular, a little more graceful, something that will allow for changing requirements over time. So everybody, when they sit down, wants to see something like this at the end. They want to see something elegant. It's, real life intrudes, and you get at least a little bit of slum architecture in almost every project. So don't feel like because you're sitting down looking at your project and it's yours, you have to defend it to the death. It's all right to say, circumstances have changed. We can go back now and we can do it better. So let's assume you've looked at your project, you've recognized it for the Rube Goldberg machine it's grown into, and now you actually want to do it. You want to sit down and you want to rewrite. How? How are you going to do a rewrite? There's 3 main strategies I've generally seen employed to do a rewrite. The first is the most dangerous. The big bang rewrite. We're just going to sit over in a corner. We're going to build an entire new glorious system. And one day we'll just turn the old one off, we'll turn the new one back on, and we'll cross our fingers. This is the most dangerous style of rewrite. It's not impossible. I've seen it done and I've done it. But it is very, very, very tough. I think really the kind of project this is best suited to is a relatively small project or a project with a very small, well-defined interface. It can work well for APIs, for example, if they're not too large and not too convoluted, particularly if they're not very stateful. For larger projects with a big interface surface, if you were rewriting a massive end-user web application with a very complicated, rich user interface, this is a terrible idea. It's probably not going to play out very well for you. If you're going to do a big bang rewrite, you need to do an awful lot of work on your test infrastructure. You need to know that the old system is compatible with, the new system is compatible with the old system in the ways that matter. You're probably going to make some backward-breaking changes as well, which is tough to deal with if you've got external users. I think the big bang rewrite is really one for small projects. If you're looking at anything very complicated, it's just not the way to go. Like that said, there are some success stories. Very, very recently, React released React 16, and React 16 was a 100% compatible total rewrite. There's a great article up on code.facebook.com that walks into exactly how they did that, exactly how they built their test framework, exactly how They made sure that they weren't introducing major bugs across the whole platform. And while I call this a success, you will not have to search very far or very wide to find people talking about the problems they had with React 16. There was a significant portion of the user base who did find, actually, this doesn't work 100% like the old project. Actually, this particular library just doesn't work on React 16 because of this one minor deviation. If you have a product with a large user base, every bug is a feature to somebody. Every slight unintended side effect that you might not even be aware of, someone's found a way to rely on it in their code base. So I would regard a successful Big Bang rewrite as a successful Big Bang rewrite that finishes with a small number of manageable problems at the end. I don't think anyone on any significant software system is going to do a Big Bang rewrite that just works out of the box straight away. So you need to not only have your plan for the rewrite, but your plan for how you're going to deal with the issues that come up at the end. The second big strategy I see is parallel old and new systems. This is more popular for in-house applications than public applications, but it does get done. The strategy here is we're not even going to turn off the old application. We're going to build a new application, and it's going to be so fabulous, people will happily move to it, and they'll abandon the old system in droves, and then one day we'll turn it off. That can be harder to do at the end of the phase of the project than you would think. In 2012, The Atlantic had an article on the last typewriter factory in the world closing down. They were wrong. It wasn't the last typewriter factory in the world. There are still many typewriter factories in business churning out typewriters to this day. I'm sure, particularly for the type of people in this room, it's almost incomprehensible that somebody would pick a typewriter over a cheap laptop. But there you are. So if you were looking at the two application strategy as a way to get rid of the typewriter, it's still a work in progress and it hasn't quite finished yet. And that goes for any two application. No matter how wonderful your new application is, you will find that somebody out there is a die-hard lover of the old application and will not want to move. So towards the end of that project, you're going to have a strategy for how to deal with the holdouts. Maybe your strategy is simply, we're going to turn it off. Tough luck. Ah, well. I saw an interesting post the other day from someone retiring an old API, and what they did was every month they put a slightly longer wait statement in a few key places in the API to sort of add a stick to the carrot of the shiny new features. So this is a very low-risk strategy in that you've always got the old application to go back to. It's an expensive strategy because you're going to have to maintain the old application. You're going to have to keep it working. And like I said, if you've got a very large user base, you're going to have a very large base of holdouts at the end. There you go. The strategy I prefer, and that I would generally recommend for almost every rewrite project, particularly anything like an API or a web service, is commonly known as the Strangler Pattern. I believe it was Martin Fowler who coined the term the Strangler application. He has a great article up on it on his website. He named it after strangler vines, vines that grow up the outside of a tree, slowly choke it to death while taking on its form, and all that's left is the strangler vines at the end of the day, and perhaps a little dead husk of tree in the middle. And the concept is somewhat similar. What you need to do is find a way to split off some small slice of your application's functionality and divert it to the new code base. And over time, you grow that slice while retiring the smaller slices of the old application. So rather than the Big Bang approach, what you're doing is you're just picking a nugget, rewriting it to what you want, running the traffic in there, and then growing it over time. It's higher risk, obviously, than the two application system, because you don't have a second application people can fall back to. But it's still relatively low risk in that if you're strangling, you can usually use the mechanism you use to divert traffic to send stuff back to the old part of the system. It also provides a way for you to demonstrate a very quick return on investment. You can say to the business, we've got 2% of it up and running. That 2% is now doing X, Y, and Z. Here are the benefits. We're proving our concept. We're proving that this works, and that, of course, is a great way to keep the investment for the rewrite flowing. There's many ways to implement the Strangler pattern. I'm going to walk you through exactly what we did in RapidRatings. And first, I'm going to tell you where we started. So we had 3 very large, very convoluted PHP code bases. They directly inspired me to use the Rube Goldberg machine slide. And yet again, they weren't broken. They worked. The business was operating day to day. In short, the elephants did indeed dance. But elephants are not great dancers. It did not dance well. It did not dance gracefully. And what our engineering staff spent most of their time doing is a bit like this gentleman here, out with a shovel dealing with the side effect of a dancing elephant rather than doing anything productive. Rather than teaching the elephant exciting new dance moves, they were just shoveling shit. And they were so convoluted that was 99% of the engineering department's time right there, shovel in hand. So we decided something had to change. So what did we rewrite to? Well, we went from PHP to, shock, surprise, Python. Python, Django, and Django REST framework. I'm not going to spend any time on this because you could have an entire talk in and of itself on how to choose your web frameworks and tools, etc., etc. Suffice to say, if you're here, I hope you think Python's awesome, and this has worked out pretty well for us. So our first attempt at strangling the application was a total failure. The mechanism we tried to use to strangle was essentially the URL routing in the Django framework. What we did was we had a default view. If you didn't hit a specific view in URL resolution, you'd be sent to the default view. The default view was actually a proxy that called through to the old PHP application. We did some minor modification to the old system so we could send it a special header. If it got that header, it would turn off your standard website L-shaped navigation and just give you back the body of the page. That let us put the navigation in one place in the new application with no duplication. And off we ran. And what we quickly found was that the PHP rarely did the same thing in the same way in more than one place. There were just too many edge cases whereby the proxy didn't handle a header properly, or a streaming download was far too large, or whatever else. And after a few months of trying to get this reliable enough to actually put it in production, we gave up. It was too brittle a mechanism. The job of building the proxy view was just too hard. That might work on some simpler applications, but it didn't work for us. So we threw it in the bin. We threw out the proxy view, and we went on to a second different way of strangling. So what we then switched to was we set up a subdomain per web application. So the main application was on our .rapidratings.com domain. So we put up the new application on a .rapidratings.com domain. We configured the web servers so they would accept wildcarded session cookies. So as long as the session cookie was from a .rapidratings.com subdomain, all of the applications could read the session cookie. Then we used a custom session library. The project it was based on is called Django PHP Bridge. It's out there and up on GitHub. We customized it a little. Some of the things that the old PHP applications were sticking in sessions simply couldn't be represented straight off in a Django session. So we actually altered Django PHP Bridge to store Django sessions in a PHP format in the database. And that way, no matter which application you landed on, the application got the cookie, it looked the session up in the database, it got the session back, and we could transparently flip you back and forth between the two subdomains. So essentially, if you looked down our navigation bar and inspected what the destination of the links were, one might go to a.rapidratings.com, another to b.rapidratings.com, another to c.rapidratings.com, but to a non-technical user, they were always on the same website. Where we did take a bit of a hit was we duplicated the navigation logic. We built a single library for our collection of Django applications to use, which rendered the navigation, and we kept the PHP logic for rendering the same logic. That results in a bit of duplication of effort, but it's usually just a case of I'm adding a URL, I'm slightly changing a URL. Anytime we took a slice out of our original PHP application and rewrote it, we simply updated our navigation to point to the subdomain of the newer application. If it wasn't working out, we roll back and it's pointing to the old application. Now, we're using subdomains to do this job here. there's a simpler way to do it, which is just to use a load balancer. If you've got something like HA proxy or the like at the edge of your network, you could simply have HA proxy say, deliver these URLs to this system, deliver those URLs to that system. We didn't have any load balancers in place, and we had a somewhat convoluted network architecture at the time. So we didn't use something like this. And the subdomain thing works out pretty much just fine for us. But if you've already got load balancers or you're planning on putting them in soon anyway, just splitting the traffic at the load balancer is a great way to go. It's also a very quick way to roll back. If you deploy your newest slice and you start setting the traffic to it, and you suddenly see a huge spike in error rates or user complaints, you can simply go to your load balancer config and send the traffic back the way it came, and happy days. So the key strategy here is to pick the smallest piece that provides some sort of value, rewrite it, deploy it, verify it before you move on to your next small, tiny slice of cake. Feature flags are one useful tool for this, in that you can build code up in the new code base and then finally turn it on. But be a little careful here. You need to really define what you mean by released and deployed. We hit a spot in time at one point in the rewrite where we had an awful lot of code which was deployed but not released. As in, it had been rewritten, it had been deployed to the new application servers, but we'd never redirected the traffic. And we were verging on the point of an accidental big bang rewrite. Everybody always wanted to put in a little bit more, add a little bit more, test a little bit more before they finally wanted to turn it on. They were overly nervous about finally turning on the new code. So if you use the big bang rewrite technique, be very disciplined about what you consider to be done. If you're not, you're going to do a big bang rewrite by stealth, and you will inherit all the problems for that. It's really, really critical that it's a small piece at a time, that it gets into the hands of real end users, that you verify it's genuinely working. When we realized what was happening with this accumulation of code, we called a complete stop. We said, no new work is being done until everything that's currently in a sort of a deployed but not released state is finally released. And sure enough, when we did that, we found an awful lot of that code was sort of 95% done. There was a 5% still left to be done, or a 5% that hadn't been talked about, or a little slice that didn't work the way we thought it was. And it took us a couple of months to clear that backlog of not really done code. So be really strict with yourselves. Make sure if you're doing this kind of technique that you're not essentially building up a big bang release by stealth, because then you really haven't gained anything by using this strategy. The next thing is to bear in mind that if you're doing a rewrite, you're probably bringing in new technologies, new tools, maybe an entirely new language. If it's a new language, if it's one you're not familiar with, it's worth investing the time to get familiar with it, to get involved with its paradigms, its thinking practices. Otherwise, what you wind up with is a shiny new car still being towed by a horse. The link in this, the dirtsimple.org article, is an account of basically a team of Java developers who set about building a desktop application in Python. And they were having a lot of problems with performance. They were wondering why everything was slow. And the answer was, you don't need deep class hierarchies. You don't need big factory patterns. They basically wrote Java code in Python, which meant they weren't playing to Python's strengths. The guy managed to fix almost all of the problems in this project and bring the speed up really dramatically just by using idiomatic Python rather than Python using Java idioms. And that's a very common thing that happens, and it can happen on a subtler level. If you, for example, in our case, the PHP, are picking up a page from an old PHP application and you simply translate it directly to Python, you're missing a huge opportunity here. It's probably not working the best way it could. It might not be necessary at all. It's worth actually sitting down and looking at the page and going, what's this doing? Why do we need it to do that? Does it need to do it at all? Is there a better way to do this? Don't look at the rewrite as just a way to change technology platforms if that's what you're doing. It's a way to change your whole application. It's a way to change your processes. It's a way to change your way of thinking. Simply, if we had simply picked up the old PHP application and dropped it into Python, we pretty much would have gained nothing. It would have been a pointless exercise. We would have had some nicer testing frameworks and tools. Certainly wouldn't have been worth the investment. we threw out entire sections of the PHP application. We dramatically simplified workflows that had gotten convoluted over time. And that's pretty much all there is to that. Don't blindly rewrite old code in a new platform, or you're not going to get a whole lot out of it. So, leading on from that, a rewrite is a golden opportunity to improve your actual knowledge, your actual business processes as a whole. We made some very key architectural decisions that were part of the rewrite. For example, the old applications couldn't be load balanced. So a rule for the rewrite is if you want to check code into the rewrite code base, it can't use the local disks. We had little stashes of data files here, there, and everywhere that were siloed off, and the various applications couldn't reach without an awful lot of pain and Rube Goldberg machines to get to them. So we said, no more local disk. If you want to write a file, it's got to go to S3. Code that used to write local files, goodbye. Until you port it to working to S3, you're not doing it. If you're using some sort of crazy local state that's specific to an application server, that has to go. You have to find a new way to do this that can sit happily behind a stateless load balancer, or it doesn't get into the rewrite. One of the bigger organizational changes, we said everything has to be completely automated. If you've written a part of this system and it doesn't work on a 100% automated deployment script, it does not make it into the rewrite. As far as we're concerned, if it's not automated, it does not exist. A system that you've written that works, that cannot be automatically deployed, is not finished, and we can't use it. We decided all new code had to have tests and had to have continuous integration. We decided it had to be secure from day one. We religiously reviewed the new code and tried to get rid of every security bug we could find. So this is an opportunity not just to get a new shinier code base, but to get new and improved processes. Anyone who's ever tried to automate an old system knows that it's a nightmare. It's much easier to bake it in from day one. It's much easier to standardize from day one. This is a much easier way to, in some cases, I would say a rewrite project is an easier way to get automation than trying to automate an old, complicated system that hasn't been built with it in mind. You really have to, draw that line in the sand. You have to say, these are the standards for the rewrite. If you don't meet the standard, the code's not going in. Changing people's way of working, saying to them, now you have to have a test suite. No, you have to wait for continuous integration to finish. It's your responsibility as a developer to make sure this can be deployed in an automatic manner. Those are tough changes to make. It can be harder to change how people behave than what technologies they use or what techniques we use. And I would say one of the harder changes we brought in early on in the project was we insisted that all code had to be code reviewed. And this wasn't so much a technology decision as a process and a people decision. Some of you probably do code reviews already. Some of you probably don't. But when you bring it into an organization as a strict rule for the first time, it's really tough. A lot of people feel very threatened when they start this process. Almost everybody gets to the point where they don't want to deploy anymore without a code review, and they don't want to check in with a code review. But the early days, people who aren't used to that process can sometimes feel that they're being personally attacked. People who aren't used to exposing their code in an early stage can feel almost a form of stage fright about putting the code up. So what I would recommend there is this book, Switch. And this doesn't just go for code reviews. This goes for everything. This book is a marvelous analysis of how to change the way people work, how to change culture, I guess, effectively. It's a long list of case studies about how people change the way organizations work, how they change their processes, how they change their behaviors. One of the early examples was trying to get doctors to adopt standard checklists for medical operations. Now, you had some very experienced doctors going, I've been doing appendectomies for 20 years. I know how to do an appendectomy. I don't need a paper checklist. They felt somewhat similar to the programmer, experienced programmer being told he had to have his code reviewed. I don't need a code review. I know what I'm doing. They took it very personally. I'm not going to go into the nuts and bolts of it, but they literally set a target of, I believe it was something like 100,000 lives saved a year. And statistically, they hit it. That's one of the better case studies in here. And that's what this book is full of. If you're going to try and make those kind of changes in an organization, I really recommend reading this. It really sets out a very solid framework for how to guide people through those kind of behavioral changes, and not in a nasty way either, in a sort of a very organic, natural way. So some of the pitfalls of rewrites, some of the things that can go badly wrong. This is what's called the second system effect. It's a great page on this in the C2 wiki. This is particularly dangerous if you're rewriting your own software project. You learn a lot when you write the first version of any software. And every developer sits down and thinks, if I was doing this again, I would do this, and I would do this, and I would do this, and I would do this. And then they get the opportunity to do the rewrite. And they take on far too much. One of the key things to take in is your rewrite is not going to be perfect. It is not going to be an ideal software system. You're not going to get absolutely everything right the second time around. If you do try and build a perfect system, you will get bogged down. Your rewrite will drag on forever, it won't deliver, and the project will be canned, almost without doubt. To give you an example from our own rewrite, the database schema we inherited was very convoluted. It made what should be some very straightforward and simple queries extremely expensive. It was a painful decision, but we said, schema is not part of the rewrite. We're going to live with the schema we've got. It adds too much expense to the rewrite right now, and we can get more than enough gains in other places. We decided that while we desperately needed better monitoring tools, that's not part of the rewrite either. We don't have time to do everything right now. We have to draw our line. Some of these are very tough decisions. You can imagine how many engineers would be in a room screaming, what do you mean we're not going to do the monitoring system? Now, you'll get to revisit these decisions later. That doesn't mean never, it just means not right now. We've just begun rolling out the improved monitoring system 3 years after we started the initial rewrite. You can go and you can tackle this stuff at a later day. You've got to narrow the scope of the rewrite at the start. You've got to decide what's important or what's not. If you try and do everything, you will wind up with the world's most useless pocket knife. It won't even fit in a pocket. Like, nobody is ever going to use this day to day. Sorry. A second very related topic is the temptation to take on way too much new technology. It's very tempting, you know, if you've had a system, you've been working on it for 6 or 7 years, it's very tempting to say, well, we're going to move it into the cloud, we're going to go serverless, or we're going to go Kubernetes, we're going to go NoSQL, blah, 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 blah. We all like to play with the new shiny toys. I would say if you're doing a rewrite project, you should only really be talking about changing 1 to 2 key pieces of technology at a time. People underestimate just how much is involved in switching to a fundamentally new technology. Going from standard SQL basis to NoSQL isn't just a matter of learning some new config files and how to bundle up a new server. It involves new ways of thinking, new best practices. It will probably take you a year to be truly comfortable with a fundamental technology change, and 2 or 3 to be expert with it. So the more fundamental technology changes you roll in, the more risk you're taking on. The bigger your chance of failure. Dan McKinley has a great article on choosing boring technology, which is essentially the same message. And he uses the metaphor of little tokens. You get X amount of tokens per project, and if they buy big technologies, he kind of rates the different levels of technologies with token cost and gives a budget per project for success. It's not a golden rule, obviously, but it's a very useful way of thinking about it. So I guess that brings us to, how did our rewrite project go? I would say it's an absolute success. And I say that by the standards of rewrite projects. We still have some of the old big PHP systems sitting around 3 years later. We did not stop all work to do nothing but rewrite for 3 years. Rewriting just became part of the process of the company. We've released entirely new systems, and we've radically changed existing systems while we've been doing the rewrite. The small slice strangler pattern means you don't need the whole team involved in this round the clock. I'd say at any given point in time, maybe at peak, 1/4 to 1/3 of the staff were doing rewrite activities, and that would have been an extraordinarily high amount. So we've now got a system that's completely automated. We've now got a system where for the new parts, it has a very thorough, very intricate code base. It's not a perfect system. There's still stuff we want to change. And I guess what we're getting closer and closer to now, and what I would really see as the ultimate end of a successful rewrite, is that it turns from a rewrite project into more of an ongoing culture of rewriting and refactoring. It's been said that any software system that doesn't get changed is basically a dead system with no users. You will never hit the point where you're done and your system is perfect. So the goal should be, towards the end of your rewrite, rather than going from old system to new system, you should be building the new system in a way that if it's well architected and clean, you can move to refactoring rather than rewriting as you need changes and improvements. And that should be a gradual blend. There probably shouldn't be a hard stop date where you can go, that's the day we finished the rewrite. You just realize one day, all that old stuff is gone, and now we're just continuously improving what we've gotten. And I think for an organization that doesn't have a healthy continuous improvement culture, our rewrite project is a wonderful way to get it. And that's pretty much it for me. Anyone got any questions? We don't do test-driven development religiously, as in not every feature gets a test before the code is actually written. Every feature has to have a test before it can even be considered for release. All versions of the software have to go through a continuous integration process before we will release it as well. On a broader sense, I've seen two strategies to tests, I've personally done two strategies for tests and rewrites. On a Big Bang rewrite, for example, we've spent 2 months writing a large test battery for a project that didn't have any tests at all, so that we could verify that the new system was accurately replicating behavior. But that was a relatively small project, and even for a relatively small project, it took 2 months of nothing but test writing to get there. For larger, very complicated products, I don't necessarily recommend writing the tests for that project up front before you begin the rewrite, because it can be incredibly expensive to test a distributed system with a lot of interdependencies. In that case, I would write the tests for the new system as I built it and try and get to the same level of coverage.
Thanks for the great talk, Sean. So, simple question, Python 2 or Python 3? And if you were to make that decision again today, would you make the same decision?
Yeah, that's a fantastic question. We did this rewrite was almost all Python 2 at the start, about 3 years ago. The most recent portions that we've done have switched to Python 3, and we're now running a mix. At the stage that we started Python 3, still there was quite a few key libraries out there that we used that hadn't been ported. Now there are. To be honest, what's really driving the move towards Python 3 now is that Python 2 has a definite end-of-life date in sight, so we do not want to be caught short-footed and having to do that in the short term. I think Python 3's performance has finally gotten to the point where that's not much of a consideration either. In the early days, you took a hit if you did that. I think if I was starting any rewrite project today, Python 3 would be my default way of thinking. There would have to be something special going on for me to say Python 2 is the way to start a new project now. Thanks, Alan.
Thanks. I think it's time to move on to our next speaker now, but can we thank again our keynote speaker, Sean?
Thank you all very much.